Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Welcome all of you to Science Champion. In this video we are going to discuss about types of resistors. In the previous one we have talked about the resistance. Now we will discuss about what is resistors. So resistor is an electrical component which provides the specific amount of opposition to the flow of current. That opposition to the flow of current is the resistance, and those electrical components which are providing this resistance is called resistor. There are various types of resistors. It can be a fixed value or it can be a variable value. So if it is having the fixed value, so it will be the fixed resistor, or if it is having the variable value, so that you may change the resistance of the resistor, so it is called the variable resistor. The value of resistor is called resistance, and it is denoted by capital letter R, and the unit of resistance is ohms. There are the symbols for fixed resistor and the variable resistor. Fixed resistor means you cannot change the resistance of the resistor, like you cannot change the resistance of the bulb. Variable resistor, like you can change the resistance of that electrical appliance, like for example the fan. You can change the speed of the fan with the variable resistor. A resistor is an electrical component that limits or regulates the flow of electrical current in an electronic circuit. There are two types of resistors, fixed resistor and the variable resistor. Now we will discuss what is fixed resistor and what are the variable resistors. Fixed resistors are the most frequently used resistors in the electronic circuit. These resistors have the fixed resistance value. Hence, it is not possible to vary the resistance of the fixed resistor. The device which only restricts the flow of electric current to a certain level but does not vary or control the flow of electric current is called the fixed resistor. Look at the fixed resistor in front of you. It is having different color bands on it, and those different color bands tell you the amount of resistance that they are providing, but you cannot change the amount of resistance provided by the fixed resistor. Here are some different types of fixed resistor, like carbon composition. You have metal frame, metal oxide frame, resistor networks, and wire wound resistors. These all are the fixed resistors, means they have a fixed value of resistance they are providing. Then we have variable resistor. Variable resistors are designed so that their resistance values can be changed. For example, a potentiometer is a 3-terminal variable resistor used to divide voltage. A rheostat is a variable resistor used to control the current. You have the symbols in front of you. The first symbol is for potentiometer. Then second symbol is for rheostat, that is the variable resistor. Third, potentiometer connected as a rheostat. These are the different types of variable resistors in front of you. Here are some symbols. Fixed resistor, we denote the fixed resistor with the on left hand side, two symbols are there for the fixed resistors, and on the right hand side there are two symbols for the variable resistors. Now we will discuss some important things about the arrangement of resistors in the series and the parallel circuit. Remember one thing, when the resistors are arranged in series, resistance is maximum. As in series there is only one path, or there is the hurdle, and all the hurdles are arranged in only one path. So the total resistance of all the resistors will be the sum of each resistor present in the circuit. You have the formula. Resistance equivalence resistance is equals to R1 plus R2 plus R3 and so on, and the SI unit of resistance is ohm. The total resistance of resistors in series is equal to the sum of their individual resistances. Like look at this example in front of you. There are 6 resistors arranged in series, and the total resistance of this circuit will be the sum of these all. Like you have the formula when resistors are arranged in series, equivalent resistors, or you may say total resistance is equals to R1 plus R2 plus R3 plus R4 plus R5 and plus R6. So R1 is having 2 ohm resistance, R2 is having 4 ohm, R3 is having 6 ohm, R4 is having 3 ohm, R5 is having 1 ohm, and R6 is having 2 ohm. So the total resistance will be the sum of these, that is the 18 ohms. Got it? So 18 ohms is the total resistance of these circuit provided by the all the resistance. Now we will discuss about the parallel resistance. Resistors when they are arranged parallel in a circuit. Remember one thing, if the resistors are arranged in parallel, so their resistance will be the minimum, but in series it is maximum, or they offer less resistance when they are arranged parallel to each other. When R is arranged in parallel, so they have more than one path, like you can see in this circuit diagram. So opposition to the flow of charges will be low. The formula for calculating the total resistance provided by all the resistors arranged in parallel is 1 divided by R total is equals to 1 divided by R1. R1 is the first resistor plus 1 divided by R2 plus 1 divided by R3 and so on. Like look at this circuit diagram on the left hand side. There are three resistors are arranged in the circuit. They are parallel to each other, and each resistor is providing you 900 ohms resistance in the circuit. So we will use the formula that is having for parallel circuit. So when the resistors are arranged parallel to each other, we have the formula 1 divided by R total is equals to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. You will put down all the values. R1 is having 900 ohms, R2 is providing 900 ohms, R3 is providing 900 ohms. You will solve it and you will get your answer. Remember one thing, after taking the LCM and the reciprocal of RT, you will get your answer. So don't forget to take LCM as well, and don't forget to reciprocate to get the answer of R total. Otherwise, you will get the answer of 1 divided by R total. So the final answer will be 300 ohm. Jazakallahu khair.